Hi, this is Chem 121, Chapter 4. These are the last two sections of Chapter 4, Sections 4.10 and 4.11. So in Chapter 4, we've looked at chemical bonding, valence electrons, the ionic bond model, Lewis structures, chemical formulas, the structure of ionic compounds, recognizing and naming binary ionic compounds. In these last two sections, we're going to look at polyatomic ions and chemical formulas and names for ionic compounds containing polyatomic ions. So all of the ions that we've looked at so far are what are called monatomic ions, meaning that the ions consist of just a single atom, like a nickel or a sulfur or a zinc or a chlorine. In this section, we're going to look at what are called polyatomic ions, meaning an ion that consists of a group of atoms bonded together. So sulfate is an example of a polyatomic ion, more than one atom, polyatomic, but they still have a charge. So in a polyatomic ion, the entire group of atoms acts as a single unit, and I posted a sheet of the polyatomic ions that you'll be responsible for in the handouts module. So sulfate is an example of a polyatomic ion that consists of sulfur and oxygen and has a charge of -2. Most polyatomic ions have a negative charge. Two of the negatively charged polyatomic ions have names that end in IDE, but most polyatomic ions either end in ate or ite. So hydroxide and cyanide are exceptions. Most of the polyatomic ions end in either ate or ite. And a number of pairs of ate and ite ions exist. The ate ion always has one more oxygen than the ite ion, but both the ates and the ites have the same charge. So that'll help you sort of remember them. The number of pairs exists where one member differs from the other by having a hydrogen present. And the ones that have the hydrogen always, the charge is always one less than the other. So do memorize your polyatomic ions. They're in the handout on Canvas. But naming with polyatomic ions isn't actually any different. The rules don't change. You just basically have to know the name of the polyatomic ion. For example, this polyatomic ion is called hydroxide. So to use it in naming, it's just called sodium hydroxide. Just as if there was a chlorine here, this would be sodium chloride. It's just called sodium hydroxide. So nothing about the naming changes. You just have to learn the names. This group of atoms is called nitrate. So if we put magnesium together with this group of ions, it's just called magnesium nitrate. The reason you have to use the parentheses here is if you want to indicate that there's two nitrate ions, you have to put this whole group into a parentheses and then put the two on the outside. But again, there's nothing different about the naming other than just learning the names. This polyatomic ion is called ammonium. The NH4 is called ammonium. It has a +1 charge. So to indicate that there's two ammoniums to balance out this sulfate, you'd have to put the NH4 into parentheses to indicate that there's two of them. But again, the naming is exactly the same. This is just an ammonium. This is called a sulfate. So this compound is called ammonium sulfate. The rules for naming don't change. You just have to learn the names of the ions. So there is a polyatomic ion Quizlet. and a polyatomic ion naming mnemonic if you want to use these, and they're also in the modules on Canvas. So to write the chemical formula from the name, the chemical formula is determined in the same way as those for ionic compounds. You just have to know the charge of the ion, the charge of the polyatomic anion, and then you just put those together to cancel out the charges. So if you have a positively charged magnesium and a negatively charged nitrate, where in this case the negative charge applies to this whole group of atoms, one single negative charge applies to this whole group. So one negative charge for the whole NO3. So since this magnesium is a +2, you need 2 of these NO3s to cancel out that negative charge. And if you want to indicate that there's 2 NO3s, then you have to use this 2 as a subscript to show that there's 2 of them. Similarly, so these are from the previous slide where we had MgNO3. And if you have an NH4 plus, where the plus charge applies to the whole polyatomic ion, and you want to use that to balance out the -2 charge of the sulfate ion, which is for the whole ion, it's not just for the oxygens, well, then you need 2 of these. And to indicate that there's 2 ammoniums, you just put the NH4 in parentheses, and then that balances out the -2 charge for the sulfate. So to write the names of these compounds, you just need to know the names of these 2 polyatomic ions and the name of these 2 cations. So take a moment, see if you can go and figure those out. So this would be sodium for the cation and sulfate for the anion, and calcium for the cation and phosphate for the anion. To write the formula from the name, it's the same as what we did before, only now you need to be able to figure out the formulas for these polyatomic anions, or polyatomic ions. So here's just magnesium, potassium, calcium, and sodium. But then you'd need to know the formulas for these polyatomic ions to write these formulas, and the charges. You need to know the charge for the magnesium and the nitrate, and then combine those into a formula where the charges would cancel correctly. So I'm going to go ahead and write these down so that I can do them on the whiteboard. Magnesium nitrate, potassium chlorate, calcium hydroxide, and sodium bicarbonate. So if you want to take a minute and go download the sheet with the polyatomic ions on it, and take a minute to see if you can solve these, and then I'll work them out on the dry erase board. So we have magnesium nitrate. So magnesium is in group 2, so it would have a +2 charge. Nitrate is this group of ions that has a -1 charge. So we would need 2 of these polyatomic ions to balance out the +2 charge for magnesium. So we would write Mg, and then we would need 2 nitrates. So we would put parentheses around the NO3 to indicate 2 of those. Potassium chlorate. Potassium has a +1 charge because it's in group 1. Chlorate is ClO3, and it has a negative charge. So this whole thing has a single negative charge, so it would just be KClO3. The next one is calcium hydroxide. Calcium has a +2 charge because it's in group 2. Hydroxide has a -1 charge. That's the polyatomic ion. We would need 2 of these negatively charged hydroxides to balance out the +2 charge on that calcium. So if you want to indicate that there's 2 hydroxides, you have to put parentheses and the number 2. And then finally, sodium bicarbonate. Sodium would have a +1 or a +1 charge. And then bicarbonate is HCO3 minus. And that's just a plus and minus. So NaHCO3. So here's sort of a combination of all the different things we've done in this chapter. Regular compounds, compounds with polyatomic ions, and compounds that will require a Roman numeral. So remember, if it's not in group 1 or 2 or aluminum, that compound's going to need a Roman numeral. So go ahead and pause your recording, take as long as you need, and see if you can figure out the names of each one of these compounds. Okay, so hopefully you took a few minutes to work on this. This is going to be potassium, and this polyatomic ion is called nitrate. This is going to be sodium. This polyatomic ion is called cyanide. This compound is going to require a Roman numeral because tin is not in group 1, 2, and it's not aluminum. This polyatomic ion is hydroxide, which has a -1 charge. There are 4 of them, so 4 times -1 is -4, so this tin is going to have a +4 charge. This polyatomic ion is ammonium, and this polyatomic ion is called sulfate. This last compound is calcium, and the polyatomic ion is called carbonate. Here's some links for ionic nomenclature practice and just a Socratic video about ionic nomenclature. And that's all for chapter 4.